There are two structures rising above and below the center of our galaxy, each one nearly 25,000 light-years tall, invisible to your eyes, yet blazing with energy no one can fully explain. They were not there in ancient star charts. They were not there in any human memory. Somewhere near that same galactic center, a star was clocked moving through space at nearly 2.5 million miles per hour, fast enough to escape the Milky Way entirely, fast enough that one day it will leave our galaxy forever and drift alone into intergalactic space. Something violent flung it there, something we are still trying to understand. How can something like this exist? My name is Vega. I've spent most of my life staring upward, trying to make sense of a galaxy that, the closer we look, keeps refusing to make sense at all. Tonight, we're not going to look at the Milky Way the way you've seen it before, as a calm spiral of stars drifting quietly through the dark. We're going into its anomalies, its wounds, its unanswered questions, because our galaxy, it turns out, is far stranger than the postcard image suggests. Let's start with those two towering structures I mentioned, what astronomers now call the Fermi bubbles. They were discovered in 2010, not through a telescope pointed at visible light, but through NASA's Fermi Gamma Ray Space Telescope, an instrument built to detect some of the highest energy radiation in the universe. A team led by astrophysicist Doug Finkbeiner at the Harvard-Smithsonian Center for Astrophysics was combing through years of accumulated gamma-ray data, trying to filter out background noise, when a pattern refused to disappear. Two enormous lobes, symmetrical, extending far above and below the plane of our galaxy, glowing faintly in gamma rays that human eyes could never perceive. Think about that for a moment. These structures are so large that if they were visible to us, they would dominate half of our night sky, and they had been sitting there undetected for decades of modern astronomy, simply because no one had built an eye capable of seeing them. So what could produce something that massive? The leading explanation points to our galaxy's very own supermassive black hole, Sagittarius A star, sitting quietly at the heart of the Milky Way. Some astrophysicists believe that millions of years ago, this black hole went through a violent feeding episode, tearing apart nearby gas clouds and blasting the leftover energy outward in colossal jets. Others propose a different origin, a sudden burst of star formation near the galactic center, with waves of supernovae exploding in rapid succession, driving material outward in a galactic-scale wind. Both explanations are plausible, both are still debated, and that right there is one of the quiet truths of modern astrophysics. Sometimes the honest answer isn't a clean discovery, it's a genuine disagreement among brilliant people staring at the same data. Personally, I've always found it incredible that the universe consistently turns out to be stranger than our imagination. We spent so long thinking of the Milky Way as this settled, familiar place, and then gamma-ray telescopes reveal that our own galactic core may have once erupted with enough force to shape structures spanning half the galaxy's width. If you're finding this as unsettling and as thrilling as I do, this is exactly the kind of journey I want to keep taking with you. Every corner of this galaxy hides something we didn't expect, and I'd love for you to stay with me as we keep uncovering it, one anomaly at a time. Now, let's go back to that impossibly fast star. In 2005, astronomer Warren Brown and his colleagues, using the MMT Observatory in Arizona, identified something that shouldn't have existed according to the standard models of stellar motion, a star moving so fast that gravity alone from any normal source couldn't explain it. It was the first confirmed hypervelocity star. Since then, dozens more have been found, and nearly all of them, when traced backward through their trajectories, point to one origin: the galactic center. The most convincing explanation involves something astrophysicists called the Hills mechanism, proposed years earlier by theorist Jack Hills. The idea is elegant and violent at once. A binary pair of stars wanders too close to Sagittarius A star. The black hole's gravity is so extreme that it rips the pair apart,
One star is captured, pulled into orbit or eventually consumed, while the other is hurled outward with tremendous velocity, like a slingshot powered by the most extreme gravitational field in our galaxy. But here's the part that still unsettles me. We have never directly observed this event happening. We only see its aftermath, stars racing away from the center at speeds that would let them cross entire star systems in the blink of a cosmic eye. It's a crime scene without a witness, and astronomers have been piecing together the evidence for nearly 2 decades.
Some researchers offer alternative explanations that a handful of these stars might not originate from the galactic center at all, but from a now disrupted dwarf galaxy, or even from a supernova explosion in a tightly bound binary system. Each hypothesis has strengths, each has weaknesses, none has been proven beyond doubt. And then there's Sagittarius A star itself, the anomaly at the heart of every anomaly. For years, astronomers wondered whether a supermassive black hole was even the correct explanation for the strange gravitational behavior at our galactic center. The proof came from watching stars orbit something invisible at extraordinary speeds over decades of patient observation. 2 teams, led independently by Reinhard Genzel in Germany and Andrea Ghez in the United States, tracked a star known as S2 as it swung around the galactic center on a tight, elliptical orbit. At its closest approach, S2 moves at nearly 3% of the speed of light, whipping around an object with a mass millions of times greater than our Sun, packed into a region smaller than our solar system. Their work, decades in the making, earned them the Nobel Prize in Physics in 2020 alongside Roger Penrose. Imagine dedicating your entire career to watching one star complete a single orbit, just to prove that the darkest, densest object we know of is really there. But even Sagittarius A star has its own smaller mysteries orbiting it. In 2011, astronomer Stephen Gillison and his team identified a strange gas cloud nicknamed G2 on a collision course with the black hole. Astronomers worldwide watched, cameras and telescopes trained on the galactic center, expecting a dramatic flare as G2 was torn apart. Instead, almost nothing happened.
The more I learn about these objects, the more I realize how little we truly understand. Every time we think we've mapped the Milky Way's behavior, something like G2, or a hypervelocity star, or an invisible gamma-ray structure the size of half the galaxy, forces us to rethink everything. And here is perhaps the most quietly shocking realization of everything we've covered tonight. All of these nullies, the Fermi bubbles, the hypervelocity stars, the extreme orbits around Sagittarius A star, they all trace back to the same tiny, invisible point at the center of our galaxy. A single supermassive black hole, no larger than our solar system, may be responsible for reshaping the structure, the stellar population, and even the visible geometry of a galaxy spanning over 100,000 light-years. One point of extreme gravity, quietly dictating the fate of hundreds of billions of stars. Some explanations are certainly more convincing than others, but even the best of them come with open questions astronomers are still racing to answer.
And if I'm being honest, this is one of those mysteries that still keeps astronomers awake at night, because the closer we look at our own galactic backyard, the more we realize it holds secrets as strange as anything found in the deepest reaches of the observable universe. We live inside one of these anomalies. Our solar system orbits within a galaxy shaped, quite possibly, by forces we are only beginning to comprehend. And if the Milky Way, our home, can hide mysteries like these in plain sight, I have to wonder what else is waiting to be found, just beyond the reach of our instruments. If tonight's journey left you with that same restless curiosity, there's another mystery waiting for us, one hidden not at the edge of our galaxy, but deep within the warped, violent gravity of a black hole itself. Join me there, because in this universe, every answer we find only uncovers another question worth chasing.